So we're going to be looking at solving fractional equations, and I've got a simple example for us to start with. We've got 2/3 plus 4/5 equals 1 over x. And just like we've been doing with all our rational expressions, we're going to be starting out by looking for a lowest common denominator. And so we're going to do that by looking at all the unique factors in all of the denominators in our equation. And so in this simple equation we've got 3, 5, and x. So our lowest common denominator will be 15x. Now when we were simplifying rational expressions and adding and subtracting and we were multiplying each rational expression by 1 in the form of whatever factors the denominator was missing. But that's not what we're going to do now. We're going to multiply each fraction, so each expression, 2/3, 4/5, and 1 over x, we're going to multiply the entire thing by the lowest common denominator. So let's take a look at what happens. Here we go. Okay, so we've multiplied here. We've got 2/3 and we're multiplying it by 15x. So that 3 in the denominator goes into our 15 there, and we have 5 left. So we've got 5x left here. And at 4/5, that 5 in the denominator goes into that 15, leaving us with 3x. And on the other side of our equation, when we multiply 1 over x by 15x, the x's cancel out, leaving us with 15. And when we simplify that, we are left with, in our first term, 5x times 2 plus 3x times 4. Here's our 3x times 4, and 15 on the other side. And when we simplify, we've got 10x plus 12x equals 15, and that gives us 22x equals 15, divide by 22, and we've got x equals 15 over 22. Now before we started, we probably should have taken a look that we had an x in the denominator, so we knew that x could not equal 0, but that's not what our resulting answer has given us. It's been 15, it's x equals 15 over 22, and we can plug that in and check it if we're not sure that we've done things correctly. Let's take a look at another simple example. We've got 2/3 x plus 1 equals 3x over 4. Our lowest common denominator is 3 times 4, which is 12. So we're going to multiply each expression in this equation by 12. So I have 12 times 2/3 x plus 12 times 1 plus equals 12 times 3x over 4. And now I'm just going to simplify this. 3 goes into 12 4 times. 4 goes into 12 3 times. So I'm left with 8x plus 12 equals 9x. And if I subtract 8x from both sides, I'm going to be left with 12 equals x. Now this wasn't really a rational equation because I had no variables in the denominator, but it's a pretty good illustration of what happens when you multiply each piece of your equation by that lowest common denominator. Now we're going to look at something just a little bit more complicated. Okay, so we've got x over x minus 1 equals 2 over x plus 1 over x minus 1. The unique factors in our denominators are x minus 1 and x, so our lowest common denominator is going to be x times x minus 1. And we're going to multiply each expression in the equation by our lowest common denominator. So I'm going to have x times x minus 1 times x over x minus 1 equals x times x minus 1 times 2 over x plus x times x minus 1 times 1 over x minus 1. It's not as nasty as it looks. Let's do some simplifying. I can divide x minus 1 by x minus 1, and that will leave me with x squared on this side. I can divide x by x, and that'll leave me with 2 times x minus 1, plus, again, dividing x minus 1 by x minus 1, and that'll leave me with x. So now let's multiply all this out. X squared equals 2x minus 2 plus x, or x squared equals 3x minus 2. And now let's get everything all the way over on one side of the equal sign. So I can have this equal to 0. I'll just move over here and I'll have x squared minus 3x plus 2 equals 0, which I can of course factor into x minus 2 times x minus 1, and I will get x equals 2 and x equals 1. But let's go back to our original equation and see if there are any limitations. And sure enough, we see right here x cannot equal 1 and x cannot equal 0. So I know that this can't be an answer. So my answer, I think, is x equals 2. So I just want to check this last answer because sometimes you can get extraneous roots when we're solving fractional equations or rational equations. So I'm just going to plug it in and make sure it works. Here's my equation, x over x minus 1 equals 2 over x plus 1 over x minus 1. So I've got 2 over 2 minus 1, which is 1, equals 2 over 2 plus 1 over 2 minus 1. So let's just simplify that. 2 equals 1 plus 1. Well, yes, that's definitely true. So we can be sure that our answer, x equals 2, is correct. So here are your steps in solving rational equations. Number 1, find the lowest common denominator, or the LCD. Number 2, multiply each term in the equation by the lowest common denominator and then simplify each term. Solve your equation and then eliminate any solutions which are restrictions, causing those zeros in your denominator, or are extraneous roots by checking. Substitute them into the original equation. So we're going to do one more together. I'm just going to walk through these rules following these steps. Here we go. We've got 2 minus 5 over 2a equals 2a over a plus 1. I've already found the lowest common denominator, which is 2a times a plus 1. So we're going to multiply each term in our equation by 2a times a plus 1. So we're going to multiply that by 2, and then by 2a times a plus 1 times 5 over 2a. I've got a cat here destroying everything on the table. Then 2a times a plus 1 times 2a over a plus 1. And now I'm going to simplify. Okay, so I've got 2a squared plus 2a, nothing to simplify here, times 2, or 4a squared plus 4a, minus, this is going to cancel, 5 times a plus 1, and here we're canceling out this a plus 1, so we're going to get 4a squared. Sorry, this is so messy. So we're going to have 4a squared plus 4a minus 5a minus 5 equals 4a squared. Well, I can see that if I subtract 4a squared from both sides, they're going to go away. So I'm going to have 4a minus 5a, which is negative a, minus 5 equals 0. I'm going to add 5. So I'll get negative a equals 5. And if I multiply or divide both sides by negative 1, I'll get a equals 5. My restrictions here, going back to my original equation, I can see that a could not equal 0 or negative 1, and that's not what I've gotten. So I still want to check my solution, though, in the original equation. So let's just shift this up a little bit. I'm going to rewrite that equation. 2 minus 5 over 2a equals 2a over a plus 1. Sorry, this is a equals negative 5. So let's see. So we have 2 minus 5 over 2 times negative 5 equals 2 times negative 5 over negative 5 plus 1. This is our check. So I'll have 2 minus, well, this will give me 5 over negative 10, which is negative 1/2, equals negative 10 over negative 4. So I will have 2.5 equals 10 over 4, which is equal to 5/2, which is equal to 2.5. So that's what I've got. 2.5 equals 2.5. So then I am sure that my answer is a equals negative 5.